Now let's see how to put all these things together and build our computer. Okay, so we assume that we are having the memory which is 4096 by 16, and the same one we are going to have here, and then we have seen all the registers: AR, PC, DR, AC, input register, and then instruction register, temporary register, and output register. These are all the registers that I have explained you just earlier. And then instead of having arithmetic logic unit, just to simplify the matters, we are just going to have adder. Using that adder we can even perform the subtraction also. So if you want to implement multiplication and division, you will have to use the add operation many times. Anyway, having this will simplify the circuit. Okay, so instead of using arithmetic and logic, I am just using adder and logic. Okay, and how is it all connected? If you see this, the connections are mainly by the bus, and the bus is implemented using multiplexer that I have shown you earlier. I think you remember it, right? So we are going to apply multiplexer to connect all the registers, right? And now how many registers are there? 1, 2, how many registers are connected to the bus? That is what is important. Okay, so how many registers outputs are you going to connect to the bus? See this, input register is something which will get the input from the keyboard, not from the bus. It is directly connected to the keyboard, and then it will go into the ALU. That is why there is no output required from input register. Got it? And then output register is something which will get the input, and then it will get connected to the printer or that monitor. So it will not go through the common bus. Common bus is used only for the communication between these parts, right? So if you remove out this input register and this output register, and you have to connect all the remaining registers. So 1, 2, 3, 4, 5, 6 registers are connected to the bus, which means you have to read or you have to connect these bits to the inputs of the multiplexers, right? So the multiplexers will be connecting to the inputs of this, and also you are going to connect this memory to the bus. Got it? So how many units are connected to the bus? Totally 7 units are connected. So if you are having 7 units which are connected to the bus, then how many bits are required to select them? 3 bits. Why? Using 2 bits we can select only 4 items, right? So by using 3 bits I can select 2 power 3, which is nothing but 8. So I can select any one of the 8 units, but then 7 units are there. That is why one of the combination is not assigned to anyone. Now if you look at this, here the numbers are given. See this, memory is given the number 7. So it means that whenever you apply read signal, and when you choose 7 here, okay, then if you put the address from which you want to read here, that particular word will be transferred onto the bus. That is the meaning of it. And whenever you apply to this particular signals the number 1, then this particular data will be transferred onto the bus, the data which is present in AR. And if the selection bits are going to have 2, then this particular thing is going to be shifted, right? So depending on how you select them, right, how you write them. So the select bits are S2, S1, S0. Depending on what you apply to these selection bits, the data is going to be transferred onto the bus. For example, if you put the selection bits to be 111, then a word from memory will be transferred onto the bus. From memory, one word will be transferred onto the bus, right? Which word will be transferred to the bus? That now depends on what is the address that you have inserted on AR, right? Because address register is going to hold the address that will be transferred to the memory, right? Now you can think of this particular link as the address bus. Got it? So the address bus is nothing but it will connect the address register to the memory. So it will be useful in selecting the memory. And you can think of the normal bus as the data bus. In general, bus will have three parts: every bus will have three parts. One is data bus, and other is address bus, and the other is control bus. Data bus is mainly useful for transmitting the data or communicating, they're just sending the data from one point to other point. And in our case, this entire bus, whichever we are using, is actually a data bus. Nothing else is being transmitted. And then address bus is normally used to send the address to the memory. For that reason, we are having a dedicated register which is called as address register, and in the address register we are going to put the address, and from there the address is being transmitted to the memory, right? So between this address register and the memory, we are operating this bus, special bus, which is called as address register. You can think of this special bus as nothing but a point to point connection. Let's say there are 16 bits, then there will be 16 wires from address register to the decoder of memory. Got it? And the next one is control bus. This control bus will carry the control signals. What are the control signals? Like this: load input is there, increment is there, clear is there. From CPU, from the control unit hardware is going to generate this control signal, and all these control signals are going to get connected to these inputs. Since they are actually individual lines. Control lines are actually individual lines. Therefore, using the word control bus is not actually right, because they are not a kind of bus. They are actually lines, individual lines, which come from the control unit, and they will be given as inputs to this control inputs to all the registers and memory. Got it? So what are the control inputs? For example, if you take memory, the control inputs are read and write. And what is the control input for this register? Load, increment, and clear, like that. Okay, now see this. So if you want to read a word from memory, what is that we are going to do? Put the address here in the address register, and that address will be available for the memory, and immediately you just raise a signal or send a signal, control signal, to read, right? Therefore, this particular data at that particular location will be put on the bus. For example, if you want to read a instruction, then what will happen here is, see this, simple. First thing is, the program counter will contain the address of the instruction which has to be fetched. Let us say it is containing 100, right? Now this address has to be given to address register first. Why? Because from there only the address will be transmitted to memory, and from that memory we are supposed to read the word. So we have to send the data or this number 100 from program counter to this address register. So what we do is select this program counter. How can we select it? This selection is done by using this control signals S0, S1 and S2. So if you put 1010 010, then what happens is whatever is present in this PC, that will be immediately available on the bus. Got it? And now once it is available in the bus, then it is given as the input to all the registers. See this, it is present as given as input to all the registers, right? And now this particular register has to read it. That is why at that time we activate this load. So when this load is activated, whatever is present on the bus will be loaded to AR. What is present on the bus now? 100 is present. Now that will be loaded to address register, which means your memory will get the address 100. Yes, now the memory has got the address 100, which means this particular word will be activated in the memory. Got it? The word which is present at 100 will be activated. Now we have to move that word from memory onto the bus. How can we do that? We have to just select the 7, right? So here if you apply 111 now, whatever is present here, that will be transferred onto the bus. Got it? Now bus is containing the instruction from the memory. Now where do you want to load it? We have to load it in the instruction register. Now when the instruction is present on the bus, see this, It is available at the inputs of all the registers, but then who has to read it? Only instruction register. That is why the load of instruction register is going to be activated. Once you activate it, it is going to get the instruction. That is how we got the instruction from memory to this. At the same time, we want to increment the program counter. For that, we are going to give the signal, control signal, this one. So that is why it will get 101. Now, who will be generating these control signals? It is the function of the control unit. Now, when should it generate it? That depends. One after the other, all these micro operations have to be executed. See, in order to execute one instruction, we have to perform various small operations. Let's call all of them as micro operations, right? For example, giving the control signals here is one micro operation, and then giving the load to AR is one micro operation. So in order to execute one instruction, we have to do various things, right? That is called as micro operation. Then when should we apply it? For that, we need the timing signal. Got it? Now see this. What happens once you have this instruction in this instruction register is, we have to take the instruction and then decode it. How to decode it? Look at the opcode, right? So opcode has to be connected to a decoder. Therefore, we need a decoder in the control unit. Now, this decoder is going to determine what type of actions have to be performed, and then when to perform those actions. For that, we need a timing device. Got it? So now we shall see those two. But before that, what I want you to observe is, here there are few things that you have to make note of. See, all the registers are connected to the clock, and in our system we are having positive edge triggered. I hope you remember this symbol from digital. It is positive edge triggered, which means if you are having a clock like this, these are the positive edges, right? So the significance of this one is, even when you switch on, let us say load is turned on here, this is the load symbol, right? The load signal is applied here. Even though the load signal is applied at this point in the clock, load will not happen until this positive edge. This is very important, and you have to observe this one. So what I mean to say is, when you are having the clock and when all our registers are positive edge triggered, then when you apply this load input, right? So load control signal, which is 1 in this case, when you are applying that, even though our load signal has been applied at this point, at this particular point, our load will not happen till this point. Why? Because they are positive edge triggered. Got it? But then what about the output? See, load is nothing but the getting the input from the bus. But what about the output? Output of the register will be immediately available onto the bus whenever you want. It need not wait for the clock. The reason is simple. See, if you are having a register, the bits are going to be like this, right? 0 1 1 0 1 1, and they are directly connected to the multiplexers. Therefore, output is always available. For getting output or to getting something onto the bus, you need not wait for the clock, this positive edge, right? But when you are trying to load something, you have to wait for the positive edge, because all these inputs, load, increment and clear, these inputs are going to respond only when there is a positive edge. That is why they are positive edge triggered. Got it? So for example, if you are trying to move whatever is in PC into AR, then what happens is, when you select 0 1 0, right, when you give 0 1 0 to multiplexer, immediately the information which is present in PC will be on the bus, which means the input is definitely available at the input of all the registers right away whenever you select 0 1 0. But then even when you give the load at the beginning of this clock itself, until the next positive edge, the load will not happen. That is why we might not be able to do certain operations together. We might have to wait for one clock to pass, and in the next clock only we might have to do the operations. When we go to that point, I'll explain you again. Here just make a note of it, okay? They're all positive edge triggered. And then see this one, our adder and logic, it is not directly connected to the bus. If you have to send some input to this adder and logic, which is nothing but the circuit which is available in order to perform some manipulations on the data, you have to put that data either in the data register or in the accumulator or in the input, which means if you have to send some data for calculation for some operation, you have to put it either in data register or in accumulator or in the input register. Just see how they are connected. See this, the data output, the data register output is connected to adder, right? And similarly your accumulator output is also connected to the adder, and similarly input register is also connected to the adder. Now why is this so? Why do you need these two connections to the adder? Is if you are going to add two numbers, first you load one number into the accumulator, one operand, and then you call add operation, but then you know that every operation in our case is going to take only one operand. Therefore you have to load the first operand into the accumulator first, and then in the second instruction you have to write add that operand, which means the second operand will be sent into the data register later. Then both of them will be connected to the adder and the operation will get performed. So since our instructions are single operand instructions, if you have to provide two operands, you load AC first and then load DR. Loading DR is, it can be done while loading the instruction, which means along with the instruction you can provide the second operand, right? And then there are operations to load the accumulator also. Got it? And if you look at it, the output of this is always stored in the accumulator. From accumulator you can move on to the bus and you can send it anywhere. Got it? And now every register is having load 1 and then increment and then clear. Load, increment, clear, right? But instruction register is not having increment or clear, because instruction register need not be incremented at all. There is no meaning in incrementing a register, instruction. Instruction is not actually a number that we want to increment. That is why it is not required. And in input and output we generally don't do anything on those registers. That is why there is nothing there. Got it? And then what are the other things that you might have to see is, look at this input register. Now input, it is getting the data from the keyboard, and then the data will be transmitted into the circuit. From there it will go anywhere you want, right? If you want to send this data to, let us say, memory, so it has to come from keyboard to this register, and from this register to this ALU, and through ALU it has to go to accumulator, and from accumulator it has to go to bus, and from bus it has to go to memory. Got it? And similarly if you have to write something to output, you can write directly to AC. From AC it has to get on to the bus, and from bus it has to get on to the output register, and output register will be directly connected to the device that output device, either it is a screen or the printer. Got it? So now this is all about how we connected them. Now we shall see how to actually execute the instruction, all instructions using this. So before going ahead, there is one more part that we have to concentrate on. What about the decoder? One thing, right? And the second thing that we might have to see is how to devise the timing. So we can see these two, and then we can go on to execute the instructions. What are the instructions present and how to implement them? Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%. But all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.